Welcome to TCP IP Basics. I'm Dan Perry, and I'll be discussing in this series of videos the principles of the TCP IP protocols. There will be a number of videos that will cover a number of different topics. Some of the things we're going to be talking about in these videos include binary number systems, TCP IP addressing, TCP ports, NAT translation, and selected utilities out of the TCP IP suite. Now, what is TCP IP? Well, it is a protocol that's used in the Internet and most other networks today. There are currently two versions of the Internet, TCP IP. Version 4 is what's most currently used. Well over 95% of the Internet uses version 4. Version 6 is a replacement for the version 4, and as more and more users, devices get on the Internet, we're going to have to move to the version 6 to allow for additional addressing. Decimal numbers. Well, what are decimal numbers? Decimal numbers are the type of numbering system we're used to. Decimal numbers have 10 digits, 0 through 9, and then as we get to larger numbers, we use additional columns, the tens, 100s, 1000s columns, in order to represent very large numbers. Well, each digit is a power of 10. And I know this for most of us, hopefully, is a review from elementary school. But, for example, this number, 357,924, it is 3 100,000s, that's 10 raised to the 5th power, plus 5 10,000s, that's 10 to the 4th, plus 7 thousands, 9 100s, 2 10s, and 4 1s. Well, binary numbers, we only have two values, a 0 and a 1. Instead of 10 digits, we have 2 digits. Each digit is a power of 2, not 10. So we have, starting at the rightmost, the 2 raised to the 0 power, or the 1s column. We have then 2 to the 1st power, or the 2s column, and notice that as we move to the left, each time we add a power, the value doubles. So when we get into the leftmost position, or 2 raised to the 7th power, that gives us a 128. In order to figure the number, wherever there is a 1, that would be that 2 to that power value. So in this case, it's 2 to the 7th, and no 2 to the 6s, plus a 2 to the 5th, nothing in the 2 to the 4th power, or the 16, a 2 to the 3rd, a 2 squared, and then a 2 to the 0. And when you look at those numbers, that middle column, that's the decimal equivalent. We'll see in later videos how we convert from the decimal numbers to the binary numbers and back. Now, why do we use binary numbers? Well, computers use or communicate in binary numbers. It's very fast and easy for a computer to determine whether a switch is turned on or off. When an electronic switch is turned on, that is a binary 1, or we view it as a 1. When a switch is turned off, that's a binary 0. And those combinations of 1s and 0s make up our binary numbers. Each binary digit, or each of those switches, is called a bit. When we combine more than one of those switches, we get larger combinations. A bit is 2 values. If we have 2 switches working together, we have 4 possible combinations, or 4 values. So we have both switches off, both on, one off and one on to give us 4 combinations. Now, each time we add a bit, we double the number of possible combinations, and going back to the binary chart, powers of 2 chart, we saw that each time we moved one more digit to the left, or added one more digit, we doubled that decimal equivalent value. You can try this with light switches. If you have a place where you have 3 light switches, then you would have 8 combinations. The total number of combinations is the number of bits raised to the second power, or 2 to the n. So if we have 8 bits, we have 2 to the 8th, or 256 possible values. Next time, we're going to look at how we count in binary numbers.